Welcome to 2.2 Limits Involving Infinity. We will be exploring horizontal asymptotes today, and I've embedded some Desmos graphing calculator into this video, but feel free to either use Desmos or your graphing calculator. That's just a little bit harder to embed. But I love Desmos. It can really do anything that your it can't do everything perfectly that your graphing calculator can, but it really does do a good job. So let's take a look at what a horizontal asymptote is today. Let's explore first the graph of y equals 1 over x, and I did not even type in y equals 1 over x. I just typed in 1 over x, so you can totally type y equals if you want. But if we take a look, this graph obviously can't equal 0, right? It would make the denominator 0. And so we do have asymptotes in this graph, and asymptotes are either vertical or horizontal lines that our graph gets really, really close to touching but does not quite touch it. And so we're going to explore those horizontal ones today. If we take a look, we can see on this graph that as we go further and further to the right, as x gets larger and larger and larger, and I'm zooming in, and I could go infinitely to the right here, but we can see that our graph, our red line, is getting really, really close to where y equals 0. It's almost hitting the x-axis, and if we kept going and going, it would get even closer and closer to that value of y equals 0. So graphically, we can sort of see that if we zoom in and out on this graph. And if we zoom out really, really far, it basically looks like the graph is touching the x-axis. It actually isn't, but we can actually view this also on a table as well. So the way that you do that on Desmos is you hit this little settings button here. And then once you hit that, you hit this table button. So I'll do that one more time. You first hit this settings button here. And then you want to hit this little table button next. And that'll bring up the table. And we want to see what happens as x gets really, really big as we go to the right, because it looks like our graph is approaching something there. It looks like it's approaching 0. So let's type in some really, really big x values. And when I say really big, I'm going to first type in 100. And then I'm going to type in 1,000. And then I'll type in something even bigger. We'll just keep going here. And it looks like what's happening is, this one says undefined because I didn't put anything in, but basically when I plug in a really big number into our function, right, 1 over 100, 1 over 1,000, 1 over 10,000, those numbers get really, really small. They're approaching 0. So we can see that as x gets really, really big, as we're approaching infinity, as x approaches infinity, as our graph goes to the right, our y values, our graph is approaching 0. Now 1 times 10 to the negative 4th, if you do not remember what scientific notation is, that value, I did not circle that very well, is 1, and then times 10 to the negative 4th means 1, 2, 3, 4. So that number is 0.0001, basically 0. It's really small. What about as our graph goes the other way, as x values approach negative infinity, as they get really little? So what I'm doing here is I want to see what happens to our graph as x gets, still getting used to this, as x gets very small. So as we go to the left, it looks like on our graph, the y values again are approaching 0, just from underneath the x-axis rather than above it, like before. And what I'm going to do on this table is I'm going to plug in x values that are very small. They're approaching negative infinity. So I'm just going to put negatives in front of all these values that we put, since those are going to be values approaching negative infinity. And so we can see that these y values, once again, are approaching 0. They're just approaching it from the negative side. But either way, those y values are again approaching 0. So what we just saw is as x got really, really big, our y value approached 0. And as x got really, really small, again, our y value approached 0. And what we would say for this graph is that the line y equals 0 is a horizontal asymptote. A horizontal asymptote to this graph. We could even draw the dotted line here, because our graph approaches this horizontal line but never quite touches it, and that is the horizontal line y equals 0. And we can see that as x got really, really big, the limit was 0, and as x got really, really small, the limit was also 0, and that's why y equals 0 was a horizontal asymptote to this graph. By definition, a horizontal asymptote is the line y equals b for the function f of x if either the limit as x approaches infinity is b, or the limit as x approaches negative infinity is b. Basically, as x gets really, really big or really, really small, the far ends of our graph, what do our y values approach? Kind of how does our graph settle down on either extreme end of our graph? Let's take a look at another graph here. We have y equals 2 plus 1 over x squared. And I'm again going to just take a look at this graph first. So visually we can take a look at it and we can see that this graph, as we go all the way to the right, it gets really, really close to the y value of 2 over here. And then as our graph, as our graph goes all the way to the left, we again are approaching that y value of 2. And so it looks like y equals 2 is a horizontal asymptote here, the line y equals 2, because our graph approaches it but never quite touches it. So let's take a look at that in a table. So we'll hit the settings key and then the little table function, and we want to see what happens as x gets really, really big. So I'm going to plug in some really big numbers for x. The first one I'll plug in is, let's do 1,000. And we can see that our y value is basically 2. Let's next plug in a larger number. Let's plug in 10,000. All right, so I've plugged in a couple numbers here. I have first plugged in numbers as x approaches infinity, and we can see that our y value, our limit, is basically approaching 2. This is technically not 2, but sometimes the calculator can only go so close to a number before it just rounds. So this might have like 8 zeros in it, like 2.8 zeros and then a 1. So this here shows us these three values right here, these three coordinates, show us that as x gets very large, right, as x approaches positive infinity. So that part right there is the limit as x approaches positive infinity of our function. We can see that that is 2. And that's showing us that as x gets very big going in this direction, our function approaches the y value of 2 there. Then if we look at these three values here, as x gets very small, so as x is approaching negative infinity for these three values, we say the limit as x goes to negative infinity of our function is also 2, because our y values are approaching 2. I'm not sure why that just moved there, but this is showing as x gets very, very small, we again are approaching a y value of 2. And so we can see just visually on this graph that our horizontal asymptote, the value that y almost like settles down to or is almost approaching on both ends of the graph as x gets very large, approaches positive infinity, and as x gets very small, approaches negative infinity, is in fact y equals 2. So this is the horizontal line y equals 2, and so we say that our horizontal asymptote of this function is the line y equals 2. For this next example, we want to find the limit as x approaches infinity of the function sine of x over x using a graph or a table, and so I'm actually going to just be using my TI-84 to find these values. If you want to use Desmos, feel free. If you are using your calculator, make sure you go to mode and make sure that you're in radian mode. All right, so I want to see as x gets very large what's happening. So I'm going to plug in some values that get significantly larger and see what happens. So when we plug in 10, we get negative 0.054. When we plug in 100, we get negative 0.005. So we don't really know what's happening yet. And then when we plug in 1000, we get 8.3 e negative 4. What does this mean? This means 8.3 times 10 to the negative 4th, which equals 0.00083. Then if we plug in 10,000, we get 3.6 e to the negative 7, which is really close to 0, right? It's a bunch of 0.000 and then 36. So it looks like what's happening as x gets very, very large, as x approaches infinity, our y values are approaching 0. They're getting extremely small. So we would say that the limit as x goes to infinity of sine of x over x is 0. And you can also check that on your graph. If you graphed this function and you zoomed out, you would see that as the graph goes to the right, it does approach 0. All right, let's take a look at the function in blue down here, this limit down here. What I'm going to do is rewrite this and break it up a little bit. And so we can rewrite this because they have a common denominator here of x. We can rewrite this, the limit as x goes to infinity of 5x over x, right? I'm going to write them both over x, plus sine of x over x. And using limit properties, which we haven't officially gotten into, but limit properties say that if we're taking the limit of a sum, we can take the sum of the two limits, meaning we take the limit of this first piece and this second piece. This is technically one big thing. So we can actually take the limit as x goes to infinity of 5x over x plus the limit as x goes to infinity of this piece, sine of x over x. Well, we know that this piece right here is 0. Because of this. So that's a 0. And then 5x over x is really just the limit as x approaches infinity of 5. And so that is just 5 because that is a horizontal line, y equals 5. And so our final answer is just 5. Now, could you plug this whole thing into your calculator or on Desmos and enter in very large values? You would end up approaching y values of 5. So the moral of the story is if you're asked to find a horizontal asymptote, you're basically asked to see the limit as x goes to infinity or negative infinity. And if that limit exists, then that is your horizontal asymptote. You can easily use Desmos or your calculator to graph and be visual about it, and easily check by plugging in larger and larger values into a table to see what your limit is as x approaches infinity.